Isotopes. All right. So when we're talking about elements, so far we've identified some really key things, such as if I draw, let's say, hydrogen here. Hydrogen has an atomic number of 1 and it has an atomic mass of 1. What is this atomic number also the same as? It is equal to the number of protons. Very good. Now, down the bottom, we have the atomic mass. And we learned that the atomic mass is equal to the number of protons plus what? The number of neutrons. So all of the things that are found in the nucleus. Now, some elements, okay, have multiple forms. And in these multiple forms, they have the same number of protons, but they have different number of, this is wrong, I'm going to cross it out. They have different numbers of neutrons. So if that's a typo in your booklet as well, can you please fix that one? So that should be, elements have multiple forms, okay? They have the same number of protons, but they have different numbers of neutrons. Now this word here, in their nuclei, means in the nucleus. The atomic number of isotopes is always going to be the same, okay? But the atomic mass will change. So, here's what we're going to do together. Number 1, name and draw 3 isotopes of hydrogen, one with 0 neutrons, one with 1 neutron, and one with 2 neutrons. Here's how I really like to do these ones, okay? Can I get everyone just a small box in the top right of all of these? And we're going to represent how this changes a little bit as we draw it. What is the symbol for hydrogen? I've done it at the top. H. So I'm going to write H in the center of each of these. What is going to always stay the same in isotopes? The atomic number, which is the number up the top. So we can write 1, 1, 1. What is going to differ a little bit now is the number of neutrons and the mass, okay? So how we're going to use the rest of this box is we're going to use it to draw the nucleus and to draw the electrons. So let's start. In this first version of hydrogen where we have no neutrons, the weight is going to be equal to 1 because we are going to have 1 proton, and that 1 proton is going to be circled by 1 electron. Okay. In our next example, hydrogen has now got 1 neutron. So I'm going to draw basically the same thing. I'm going to draw my 1 proton, and next to it I'm going to pick the black pen here, I'm going to draw 1 neutron. And how many electrons are we going to have going around this? 1, good. The number of electrons hasn't changed. Now, what is the weight of this second isotope of hydrogen going to be? 2. Why is it 2? Because we have the mass of both the protons and neutrons. Both are equal to 1. In our final example, we're going to have our same 1 proton. And this time we're going to have 1, 2 neutrons. How many electrons are we going to have? 1. And so what is the atomic mass of this hydrogen isotope going to be? 3. Great. Okay. Now, when we're naming these isotopes, okay, we can name them as follows. We name them based on their weight. So the name of hydrogen stays the same. So this is hydrogen, but it's known as hydrogen 1. In hydrogen, the next example, what is the weight of this second hydrogen? 2. So this is what we call hydrogen 2. And in our final example, hydrogen's weight has increased 1 more time, and so we refer to it as hydrogen 3. Question? Writing blank piece of paper if you need it. Okay. So what we're now going to do is one that's a little bit more challenging. Okay, and I'm just going to do the first one for you. So we're going to do the same thing again where we start with our boxes in the top left-hand corner. And we're going to be looking at carbon now. And carbon is element number 6. Carbon has the symbol of capital C, and its atomic number is 6. Now in our first example of carbon, we have a carbon with the atomic number 6, which means how many protons are we going to have? 6. So I'm going to draw 1, 2, 3, 4, 5, and 6. In this first example, how many neutrons have we been asked to add to this carbon? How many neutrons have we been asked to add? 6. So I'm going to draw 1, 2, 3, 4, 5, and 6. So everything's all connected together. I'm sorry, mine's a bit of a mess. Now, with this carbon, okay, if we have 6 protons, how many electrons are we going to need to have? 6. And here's what I'm going to ask you to do. I'm going to ask you to trust me on this one. With these 6 electrons, we're going to end up with 2 on the inside, and that is then surrounded by 4 on the outside. And that is going to be the same in all of these examples. I'm not going to explain this idea today, but this will be in our next lesson. So for today, all I'm going to do is ask you to trust me on the electrons for carbon. What I am going to ask you to do now, though, is can you please give the next two for 7 neutrons and 8 neutrons a go. And what we'll find here is that the atomic mass for this first carbon is equal to 6 protons plus 6 neutrons gives us an atomic mass of 12. Question?
Why did you put the little dash on top of your E?
Because they have a negative charge. So I draw my electrons with the little negative symbol up the top. All right, so give question 2, parts B and C a go for me. When we look at carbon 12, the number of protons is the same as the number or the atomic number. So carbon's atomic number has stayed the same in all of these scenarios. So the atomic number, the number of protons for carbon 12 is going to be 6. The number of electrons, does that change in an isotope? The answer is no, and so that also remains as 6. In order for us to determine the number of neutrons, we take the atomic mass and we subtract the atomic number. If we, in this instance, find carbon 12, the mass is this number that exists on the end. So the mass in this instance is going to be 12 minus 6, and that is going to give us how many neutrons? 6. So now let's work on our atomic notation. This is the skill we worked on in our last lesson. When we talk about carbon, we start with its symbol. And the symbol for carbon is a capital C. I'm writing that large over on the right-hand side. At the bottom left of that C, I now fill in the atomic number. And the atomic number is 6. Above that, in the top right, I write the mass, which is 12. So what I'm going to have you do right now is, if I highlight these in the same way that I did yesterday, meaning that the number of protons, number of electrons, all of that is equal to this number here. Can I get you to please fill in this table for me for the different isotopes of carbon, potassium, and boron, and then we'll go through the examples.